Daniel Bernoulli. Daniel Bernoulli was a Swiss mathematician who came from a long line of mathematicians. He was born in the Netherlands in 1700 and died at the age of 82 in 1782 in Switzerland. He was known for his pioneering work in math, physics, and statistics. Daniel Bernoulli was the son of Johann Bernoulli, who is known as one of the early creators of calculus. Bernoulli and his father had a pretty bad relationship because Bernoulli Sr. was embarrassed by the fact that his son was a better mathematician. In fact, his father was so jealous that he plagiarized some of his son's work from his first novel, Hydrodynamica, for his own book, Hydraulica, and then lied about it to the public. As a child, Daniel studied business and medicine because his father asked him to, but the condition that Daniel put forth was that his father would have to teach him mathematics privately. Throughout his life, Daniel was good friends with Leonhard Euler, another Swiss mathematician and physicist with whom he worked for many years. In 1750, Bernoulli was elected to be a member of the Royal Society, a select group of advanced engineers and scientists of the time. Bernoulli's work in mathematics. In 1738, Bernoulli wrote Hydrodynamica, in which all of his work and theories focused on the core theory of the conservation of energy. He and Euler worked together to find out more about the flow of fluids, another interest of Bernoulli's. Bernoulli's experiment was to puncture a pipe with a small open-ended straw, and he deduced that the height to which the fluid rose in the straw was related to the pressure of the fluid itself. For about 170 years following this discovery, doctors throughout Europe punctured people's arteries to determine blood pressure. But Bernoulli's method of finding pressure is still used to measure airspeed on planes today. Bernoulli also came up with a mathematical law that dictates how a moving fluid exchanges its kinetic energy for pressure. The equation can be seen here. P represents pressure, and rho is the density of the fluid, and U is the velocity. This law indicates that as velocity rises, pressure falls. And another example of this law is the wing of an airplane, which is designed to create an area of fast-flowing air above its surface. The pressure of this area is lower, and so the wing is sucked upwards. This is the cover of Daniel Bernoulli's novel Hydrodynamica. Furthermore, Bernoulli also did some pioneering work in statistics. He published Exposition of a New Theory on the Measurement of Risk, in which he uses the St. Petersburg paradox as the basis for his economic theories of risk aversion, risk premium, and utility. St. Petersburg paradox is where some super naive person takes a path that no rational person would ever take, and then follows many different tangible opportunities, and there are many different solutions to the same problem. Furthermore, Bernoulli was also known for his work in physics. In Hydrodynamica, he outlined the basis for the kinetic theory of gases, which describes a gas as a large number of small particles, all of which are in constant random motion. And then he applied the idea to Boyle's law, which we use in chemistry today. Boyle's law states that the absolute pressure and volume of a given mass of confined gas are always inversely proportional. These two examples can be seen here. Firstly, we have Boyle's law. Here we can see that as pressure is applied, volume becomes less, and vice versa. If we look at this picture over here, we see the random and constant motion of particles that represent gas. Furthermore, in physics, Bernoulli also worked with Euler on elasticity to describe the relationship between a beam's deflection and the applied load. Their theory judges how much load a beam can take before snapping, and is used in many engineering models around the world. The most famous application of the Euler-Bernoulli beam theory is the Eiffel Tower. Daniel Bernoulli contributed significantly to the fields of mathematics, statistics, and physics, and his work is still studied today and applied to many different topics in the world of science today as well.